Alright, so let's go through some of your homework problems I had asked you to do on practice 10.3, numbers 9 through 20. So we'll just start working through these. Number 9, it says the log base 6 of x plus the log base 6 of 9 is equal to the log base 6 of 54. This is a product property. We could say log base 6 of 9x is equal to the log base 6 of 54. Using the property of equality, those cancel, and you'd get 9x is equal to 54, so x would be 6. If you were to plug 6 into x, you could see that that would be fine. For a problem like number 10, it says the log base 8 of 48 minus the log base 8 of w is equal to the log base 8 of 4. Well, there's nothing in front of log, so we could use a quotient property. Log base 8 of 48 divided by w is equal to the log base 8 of 4. Property of equality cancels those, and we would get 48 over w is equal to 4. Multiplying both sides by w and dividing both sides by 4, you get w is 12. Problem number 11, it says that the log base 7 of n is equal to 2/3 times the log base 7 of 8. Now you can't use the property of equality because you have a power in front of a log. So once we get rid of that, 8 to the 2/3, remember, means the third root of 8 to the second, or the third root of 8 to the second. No matter which way you do it, you get 2 squared, which is 4. So this just turns into the log base 7 of n is equal to the log base 7 of 4. The log base 7s would cancel, n would equal 4. All right, so now we're getting into some more entertaining problems. Problem number 12, it says the log base 3 of y is equal to 1/4 times the log base 3 of 16 plus 1/3 times the log base 3 of 64. We could bring those powers up. This would be the log base 3 of y is equal to the log base 3 of 2. 16 to the 1/4 is the 4th root of 16, plus the log base 3 of 4. The third root of 64 is 4. So using the product property, we get the log base 3 of y is equal to the log base 3 of 8. Property of equality would tell you that y is equal to 8. Problem number 13. It says that the log base 9 of 3u plus 14 minus the log base 9 of 5 is equal to the log base 9 of 2u. So let's use our quotient property here. Property of equality would cancel these. And we have a proportion. So what we could do is just cross multiply to finish this. 2u times 5 is 10u would equal 1 times 3u plus 14. And you'd get that u is equal to 2. You could plug it in and it will wind up working. Number 14, we have a combination of different properties. It says the log base 7 of x plus log base 7 of x minus log base 7 of 3 is equal to the log base 7 of 12. So let's try to do it one step at a time. Plus means we multiply. X times x is x squared. Subtraction means we divide. Property of equality would cancel these. We could cross multiply. 12 times 3 is 36. It's equal to x squared. Taking the square root would be absolute value of x is 6. So x would equal plus or minus 6. But we know we can't use negative 6 because that would make the argument negative. So x would just equal 6. Problem number 15. Let's see. It says 4 times the log base 2 of x plus log base 2 of 5 is equal to the log base 2 of 405. So we can't combine these yet because of the 4. So let's get nothing in front of the log here. We can multiply because we see the addition. Property of equality cancels these. Dividing by 5 on both sides. Would give us 81. And the fourth root of 81, this would turn into absolute value. This would be 3. X can't be positive or negative 3 because that would turn the base negative. So we'll just keep positive 3. For problem number 16, it says we have the log base 6 of 2x minus 5 plus 1 is equal to the log base 6 of 7x plus 10. Now you can't combine a log and 1, so let's bring this on the other side by subtracting it on both sides. We'll get 1 is equal to the log base 6 of 7x plus 10 minus the log base 6 of 2x minus 5. So that subtraction is going to enable us to use the quotient property. And at this point we get stuck. So like I had mentioned, we could use the translation property to finish this. 6 to the first is equal to 7x plus 10 divided by 2x minus 5. If we put this over 1, we could cross multiply to finish this. 6 times 2x minus 5 is 12x minus 30 is equal to 7x plus 10. So we'd get 5x is equal to 40, or x would equal 8. Number 17, we have the log base 16 of 9x plus 5 minus the log base 16 of x squared minus 1 is equal to 1/2. So let's go ahead and use the quotient property. And we could use the translation property here to get rid of log. 16 to the 1/2 power is equal to 9x plus 5 over x squared minus 1. Put this over 1, 2. 9x plus 5 times 1, cross multiply, would be 9x plus 5. 16 to the 1/2 is just 4. The second root of 16 to the first is 4. 4 times x squared minus 1 would be 4x squared minus 4. We could bring these terms on the other side. That's how we solve a polynomial. So 4x squared minus 9x, and then bring the 5 over, we get minus 9 is equal to 0. If we factor this, so let's see, factors of 4, and then 9 would be that, 12, so negative 12 plus 3, that would be how you factor. You could also use the AC method if that's easier to understand. That's called the guess and check, what I just did. X would equal negative 3/4, and here x would equal 3. If you plug 3 in, everything's fine, but 3/4 would give you a negative answer there. So the only answer for this is x is equal to 3. for number 18. Number 18 is similar to problems we've done, so you just use the product property and you should be fine there. Let's do number 19. Number 19, it says we have the log base 6 of 3m plus 7 minus the log base 6 of m plus 4 is equal to 2 times the log base 6 of 6 minus 3 times the log base 6 of 3. So first, let's see what we have here. Going to use the quotient property on this side. Log base 6 of 3m plus 7 divided by m plus 4. On the right side, I see that this is an inverse property, so we're just left with equals 2. And then we could use the power property and bring that 3 up. Base 6 of 3 to the third is 27. Alright, so let's get all the logs on one side. Now there's a few different ways we could have done this, but this is the way that I'm choosing to do it. And then I'm going to combine these by multiplying them together. So this is just going to turn into the log base 6 of 27 times 3m plus 7 over m plus 4. And that whole thing is going to equal 2. Let's get rid of the log by using the translation property. 6 to the second is equal to, let's see here, 27 times 3 is 81 m plus 27 times 7 is 189 all over m plus 4. 6 to the second is really just 36. And at this step, we're going to get some big numbers, but I'm going to cross multiply to solve our proportion. 81m plus 189 is equal to 36 times m plus 4. 36 times 2 is 72, times 2 is 144. Let's get m by itself, subtract 36 on both sides. And I'm getting m is equal to -1. Just looking at the original equation, if I plug it in, I don't get any negative arguments, so that's good. And we have one more problem to do. Problem number 20. It says we have log base 2 of 2x plus 8 minus log base 2 of 2x squared plus 21x plus 61 equals -3. So this is a quotient property. And then from here, I'm going to use the translation property. 2 to the -3rd is equal to 2x plus 8 over 2x squared plus 21x plus 61. 2 to the -8th is 1 over 2 to the 8th, and 2 to the 8th is 256. Now we could cross multiply. 256 times 2 is 512. And 8 times 256 is, should be an x here, 2048. So let's get all the x's on one side. I'll bring the 512 over. And I'll bring the 2048 over. And that's a mess. So what I'm going to do here is I'm going to use a quadratic formula, and hopefully that'll give us our answers. X would equal the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's see what that square root is. Let me just double check here. I think I might have did something wrong. So log base 2, 2x plus 8 minus log base 2 of 2x squared plus 21x plus 61. Okay. 2x plus 8 over 2x squared plus 21x plus 61. 2 to the negative. Oh, that's my problem here. Sorry, guys. I made a little mistake. I was getting ahead of myself. 2 to the third is 8, and I wrote 2 to the negative 8. So, sorry about that. Just get rid of that here. This should be 2 to the negative third is equal to 2x plus 8 over 2x squared plus 21x plus 61. Now 2 to the negative third is 1/8. And that looks a little bit better. We can cross multiply. And get everything on the same side here to solve a polynomial. 21x minus 16 is 5x. 61 minus 64 is negative 3. That's a little bit easier to factor. We have to get 5, so we could put 3 here to get 6 and 1 here. Positive 5 would be positive and a negative, and we get x is equal to 1/2, and x would equal negative 3. Now let's just check to the original problem, make sure they work. 1/2 would work there, and 1/2 would work here. Negative 3 and negative 3. So both of those answers work. So that would be our answer. All right. So I hope you understand the lesson. Please submit your quiz by midnight tonight. Thank you very much. Have a nice day.